let's do a little exercise. We're going to sweep through the text and try to review any topics that we have missed that we've done so far. So the first thing is we looked at some words, and we had words like constant. Oh, variable.
Yeah.
Yeah. Constant, variable, let's see, a term, coefficient, how do you spell coefficient? I'm going to try it. Is it EI? I know there's a rule, I before E except after C, but it never looks right when I write it.
Yeah, I think it might be I.
Okay, well, term, coefficient, it's good reason to avoid the word. Constant, variable, term, coefficient, linear, combination. Oh, and sort of like either like numerical value or explicit number. Okay. Okay, so we have words like that, and then there was a little exercise in chapter 0 about these words and some of the conventions. So what I want you to do is take this first one here. We'll just go through and answer some of these. They're similar to the chapter 0 acclimatization questions that have to do with chapter 0 ideas. So this would, if you haven't looked at chapter 0 stuff or it seems confusing, this might help you. So what I want you to do is, we'll go term by term. So first of all, I want you to ask, what is W? In terms of choose the word that best describes what this is. Okay, and take a moment and then either raise your real hand or raise your Zoom hand when you have a word chosen. Okay. Yeah. Okay. So this is a variable, right? That's what you guys chose. The reason is because it's from the end of the alphabet. And then you can sort of see that, what about B? What's that? Do the same thing, choose a word and then raise your hand. Okay. Well, of course, that's a constant. This is the default. We could choose these to be something else, but it's a constant. And then what about this is harder one. What about E? Well, there's also I think there's also some other words like algebraic expression and numerical expression. So what's E? Okay, we have one person. Two. Okay, so this is an algebraic expression, right? It doesn't actually, it's not a numerical expression because it doesn't have a numerical value. And a numerical expression has numerical value because Z doesn't have a numerical value yet. We haven't chosen it yet. It doesn't have a numerical value, so it's an algebraic expression. Okay, what about G? 5D plus 6B. What is that? Okay, with one answer. 2, 3. Okay, this is a numerical value. Do you guys agree? It's not a linear combination because these are constants. So this is just a number times 5 plus a number times b. Excuse me? Oh, yes, it could be a constant. That would also be correct. Yes, yeah, these two things are, because a constant is a name for a number that's already been chosen. So these are really going to be, I mean, maybe saying constant is maybe this is a better answer because you're saying, oh, it's a name. It's not actually, it's some complicated name for a numerical value. So it's probably better to say that it's a constant rather than, you probably say it's a constant and has a numerical value. So, okay, that's a good clarification. And let's see. I think some of these other ones are, there's one other word was, that we'll see along the way is arbitrary, which means typical. And that'll take a little getting used to. So now, last time, I think we talked one time last week about equations being propositions, and we talked a little bit about how there's these symbols, the upside down A that means for all, and the backwards capital E that means there exists, and that capitalizes on the capital of A there, the capital of E there, but this also means maybe more clearly there is at least one. Like, so you usually use these in the sense of for all variables, for all values of the variable X, or there is a value for the, this is for all values of that we could choose of the variable X, and there is at least one value for the variable X. And sometimes you'll just say for all X, or for there exists an X, which meaning that you can choose a value for that. Okay. And then, so I think, let me see. Oh, yeah. So that's just to point out, the question is 2x, is this a true statement? Well, usually, yeah. So this is one of those. This is a little bit pedantic, right? I mean, it's sort of a little bit pedantic because we know what you mean. You mean what you mean for this. If this was true, you say no matter what value of X you choose, this is going to produce a true statement. But literally, we have to sort of say, well, this is like something. It's not quite a proposition because we haven't said what we're choosing for X. And so we're going to say it's neither true nor false. It's like about to be true or false. And the point is, we can make it into a proposition. This is being a little precise here, that we can say for all X, 2x equals X plus X. So that makes explicit the choices. No matter what value you choose for X, this is true. So that means that, okay. So sometimes, like, for example, if you wanted to use this in a proof, you'd say, it's sometimes hard to work with these. So you'd say, for an arbitrary value x of a, that means, so this is a value we've chosen, but it's an arbitrary value that we can say for an arbitrary value of x of a, 2 of x of a equals x of a plus x of a. So these are really equivalent statements. However, this we're talking about some particular value that it's sort of like an arbitrary value is one that I've asked someone to choose, but I don't know what value they've chosen, and I only want to make true statements. So I can say, well, this is going to be true of the value that someone chose, no matter what value they chose. So it's an artifice. This is a little hard to work with. This is more concrete, saying this is a particular value. But it's typical, it's arbitrary. That's why this is a value in proof. So when you're trying to show something's true, it isn't something that you're completely familiar with. Okay, let me